Download this code from codegive.com, link in the description below. Deployment and sandboxing of node.js applications, a comprehensive guide. This tutorial provides a detailed overview of deploying and sandboxing node.js applications. We'll explore various deployment strategies, delve into different sandboxing techniques, and provide practical code examples to illustrate the concepts. Deployment strategies. Deploying a node.js application involves making it accessible to users on a server. There are several strategies you can employ, each with its own trade-offs in terms of complexity, scalability, and cost. 1. Simple deployment, process manager. Description *. This is the simplest approach, suitable for small projects or development environments. It involves running the node.js application directly on the server and using a process manager like PM2, nodemon, or forever to keep it running and automatically restart it if it crashes. Pros *. Easy to set up and manage. Low overhead. Cons *. Limited scalability. Not ideal for high-traffic applications. Potential security risks if the server is compromised. Example, using PM2. Installation npm install gpm2. Starting the app PM2 start app.js name my app, replace app.js with your main application file. Monitoring PM2 monit. Stopping PM2 stop my app. Restarting PM2 restart my app. Deleting PM2 delete my app. Bootstrapping PM2 start up systemd, configures PM2 to start on server boot. Saving the current process list PM2 save. This allows PM2 to remember the applications to start after a reboot. Code example, basic node.js app, app.js. 2. Reverse proxy, nginx/Apache. Description *. A reverse proxy acts as an intermediary between the client and the node.js application. It handles incoming requests, forwards them to the appropriate node.js server, and returns the response to the client. Pros *. Improved security, hides the internal server structure. Load balancing, distributes traffic across multiple node.js instances. SSL termination, handles SSL encryption/decryption. Static file serving, efficiently serves static assets like images and CSS. Cons *. More complex to set up and configure. Requires additional server resources. Example, nginx configuration, /etc/nginx/sites available /myapp. Explanation *. Listen 80, listens on port 80, HTTP. You'll usually redirect to HTTPS. Server_name example.com, the domain name for your application. Proxy_pass http://localhost 3000, forwards all requests to the node.js application running on localhost 3000. Proxy_set_header, sets various HTTP headers to ensure proper communication between the client, nginx, and the node.js application. Location/static, serves static files, example images, CSS, JavaScript, from a specified directory. This improves performance as nginx is better at serving static content than node.js. Steps *. 1. Install nginx, sudo apt update and sudo apt install nginx. 2. Create the nginx configuration file, example /etc/nginx/sites available /myapp. 3. Enable the site, sudo lns /etc /inc /sites available /myapp /etc /inc /sites enabled /. 4. Test the configuration, sudo inxt. 5. Reload inx, sudo systemctl reload inx. 3. Containerization, Docker. Description * Docker packages the node.js application and its dependencies into a portable container. This ensures consistent behavior across different environments, development, testing, production. Pros * Consistent environment. Easy to scale and deploy. Isolation from the host system. Simplified dependency management. Cons * Requires Docker knowledge. Can add some overhead. Example, Docker. * Docker file, create a file named Dockerfile in your project root. *Docker ignore, optional, create a file named .docker ignore to exclude files/folders. Build the Docker image * Docker build t-my-node app. Run the Docker container * Docker run p3000:3000 my-node app. Maps port 3000 on the host to port 3000 in the container. Push the image to a Docker registry, example Docker hub Docker push your username /my-node app. Docker compose.yml, for more complex applications involving multiple services. Running with Docker Compose * Docker Compose upd. Explanation * From Node 16 Alpine, starts with a lightweight Alpine Linux-based node.js image. Alpine is smaller than the full Debian-based images. Use a specific node.js version for consistency. Workdir/app, sets the working directory inside the container. Copy package star.json/ copies the package.json and package lock.json files to the working directory. Run npm install, installs the node.js dependencies. Copy. Copies the rest of the application code. Expose 3000, exposes port 3000 to the outside world. cmd node, app.js, specifies the command to run when the container starts. 4. Cloud platforms, AWS, Azure, Google Cloud. Description * Cloud platforms provide a managed environment for deploying and scaling node.js applications. They offer various services like load balancing, auto-scaling, databases, and monitoring. Pros * Highly scalable and reliable. Managed infrastructure. Pay-as-you-go pricing. Extensive tooling and integrations. Cons * More complex to set up and manage. Can be expensive for high-traffic applications. Vendor lock-in. Examples *. AWS * Elastic Beanstalk, ECS, Elastic Container Service, EKS, Elastic Kubernetes Service, Lambda, serverless. Azure * App Service, Azure Container Instances, Azure Kubernetes Service, Azure Functions, serverless. Google Cloud * App Engine, Cloud Run, Google Kubernetes Engine, Cloud Functions, serverless. General steps * 1. Create an account with the chosen cloud provider. 2. Create a project or resource group. 3. Choose a service, example App Service on Azure, Elastic Beanstalk on AWS, Cloud Run on Google Cloud. 4. Configure the service, example instance size, number of instances, load balancing. 5. Deploy the application, example using Git, Docker image, or zip file. 6. Configure DNS and SSL. 7. Monitor the application's performance. 5. Serverless functions, AWS Lambda, Azure Functions, Google Cloud Functions. Description: serverless functions allow you to run your node.js code without managing servers. You only pay for the compute time your code consumes. Ideal for event-driven applications and APIs. Pros: no server management. Scalable. Cost-effective for low-usage applications. Cons: cold starts, initial latency when a function hasn't been used recently. Limited execution time. Debugging can be more challenging. Example: AWS Lambda. Code, index.js. Steps: 1. Create an AWS account. 2. Create a Lambda function. 3. Upload the code, zip file. 4. Configure the handler, index.handler. 5. Set the runtime to node.js. 6. Configure permissions, IAM role. 7. Test the function. 8. Create an API gateway endpoint to trigger the function. 2. Sandboxing node.js applications. Sandboxing involves isolating your node.js application from the rest of the system to prevent malicious code from causing damage. This is especially important when dealing with untrusted user input or third-party modules. 1. Operating system level sandboxing ***. Description * using OS level features to restrict the resources and permissions available to a process. Techniques * User accounts * run the node.js process under a dedicated user account with limited privileges. Crut * change the root directory for the process, restricting its access to files outside the crut environment. Groups, control groups limit the resources, CPU, memory, I/O, available to the process. Namespaces * isolate the process's view of the file system, network, and other resources. Appermeter/SE Linux * mandatory access control, MAC, systems that enforce security policies on processes. Firejail * a Setuid program that reduces the risk of security breaches by restricting the running environment of untrusted applications. It operates through Linux namespaces and seccomp BPF. Example, using Firejail. Installation * sudo apt install Firejail, on Debian-based systems. Running an application * Firejail node app.js. Configuration, custom profile. Create a profile file, example myapp.profile, in /config/firejail or /etc/firejail. Example. Run with the profile, firejail profile equals myapp node app.js. 2. Containerization, Docker. Description * as mentioned earlier, Docker provides isolation between the application and the host system. Containers have their own file system, network namespace, and process space. Benefits * limits the impact of a security breach within the container. Simplified resource management. Security best practices with Docker *. Use a minimal base image *. Choose a base image that only contains the necessary components, example Alpine Linux. Run as a non-root user *. Create a dedicated user inside the container and run the node.js process as that user. Limit capabilities *. Drop unnecessary Linux capabilities using cap_drop. Use read-only file systems *. Mount the file system as read-only to prevent modifications by the application. Set resource limits *. Use Docker run options like -memory, -CPU shares, and -u limit to limit the resources available to the container. Use Docker security scanning tools *. Tools like Docker Scan and third-party vulnerability scanners can identify security vulnerabilities in your Docker images. Keep Docker up to date. Regularly update Docker to the latest version to benefit from security patches. Example, Docker file, running as a non-root user. 3. Virtual machines, VMS. Description: VMS provide a higher level of isolation than containers. Each VM runs its own operating system and has its own dedicated resources. Pros: stronger isolation, better compatibility with existing applications. Cons: higher overhead, more complex to manage. Use cases: running applications that require specific OS versions or kernel modules. Isolating highly sensitive applications. 4. Node.js VM module, not recommended for production. Description: the VM module in node.js allows you to run JavaScript code in a sandboxed environment within the same process. Warning: the VM module is not a robust security solution. It's possible for malicious code to escape the sandbox. It's primarily intended for running untrusted code in a controlled development or testing environment, not for production use where security is paramount. Example: limitations: escape vulnerabilities: exploits have been found that allow code to break out of the VM sandbox. Resource exhaustion: malicious code can still consume excessive resources, CPU, memory, even within the sandbox. Limited isolation: the sandbox shares the same process as the main application, so certain types of attacks can still affect the overall system. 5. Secure coding practices: Description: the most important aspect of security is writing secure code in the first place. Best practices: input validation: sanitize and validate all user inputs to prevent injection attacks, SQL injection, command injection, etc. Use libraries like validator.js or express validator. Output encoding: encode output to prevent cross-site scripting, XSS, attacks. Use template engines with built-in escaping, example handlebars, EJS. Principle of least privilege: grant only the necessary permissions to the application. Avoid running the application as root. Dependency management: keep dependencies up to date to patch security vulnerabilities. Use npm audit or yarn audit to identify vulnerabilities. Use npm check updates to help with updating dependency versions. Rate limiting: implement rate limiting to prevent denial of service, DOS, attacks. Use middleware like Express Rate Limit. Authentication and authorization: use strong authentication and authorization mechanisms to protect sensitive data and resources. Use libraries like passport.js or JSON webtoken. Error handling: handle errors gracefully and avoid leaking sensitive information in error messages. Logging and monitoring: log application events and monitor system resources to detect suspicious activity. Code reviews: conduct regular code reviews to identify potential security vulnerabilities. Regular security audits: hire professionals to perform security audits on your application. Code example, input validation. Code example, rate limiting. 3. Conclusion: choosing the right deployment strategy and implementing appropriate sandboxing techniques are crucial for building secure and scalable node.js applications. Consider the specific requirements of your project, the level of security needed, and the available resources when making your decisions. Remember that security is an ongoing process that requires continuous monitoring and improvement. Prioritize secure coding practices and keep your dependencies and infrastructure up to date to minimize the risk of vulnerabilities. By combining these strategies, you can create robust and resilient node.js applications that can withstand various security threats.